A rain gutter is made from a rectangular sheet of metal 64 inches long and 14 inches wide. The gutter will be placed along the top of a porch in order to direct rainwater away from a house. To create the gutter, the homeowner plans to take the rectangular sheet of metal and make 2 long folds X inches from the edge and then fold the sides up as shown below. Let's begin by labeling our diagram. So it says that the original sheet of metal was 64 inches long. So this is a length of 64 and 14 inches wide. And then it says that to create the gutter, they're going to make 2 long folds, and that's the dashed lines in the diagram. And those folds, it says, are X inches from the edge. So that means that we have a fold length of X here and another fold length there. That's X inches from the edge of the sheet of metal. So when you fold up those 2 sides along the dashed lines, the result is going to be the diagram on the right. So I'm going to do a little bit of highlighting here so we can see the similarities in these diagrams. We have the 14 inches in the first diagram here, and that would correspond to this distance here in the second diagram. So I'm going to label that as 14. Then we have the width of the rain gutter once the sides are folded up. That's here in blue. And so that length on the first diagram, that would be this distance here in between the dotted lines where we were making the folds. And we need to label that. So if the original length of the sheet metal was 64, but we have a length of X on this side and another length of X on that side, then the remaining distance between those dotted lines would be 64 minus 2X. So on the diagram to the right, 64 minus 2X is the ending width, we'll say, of the gutter. And then lastly, in the second diagram, we have the height of the gutter, which would basically be here as well as here. Those 2 heights are going to be the same. And looking at the first diagram, that's going to be this distance of X, or this length, I should say, of X. So the height then ends up being in the second diagram. You could label this here as X. All right, so part A asks us to write a function to represent the volume of the gutter in terms of X. So if you can imagine, if this gutter were full of water all the way to the top, then this shape that we have here ultimately is what we would call a rectangular prism. In other words, a box. And the volume of a box or a rectangular prism is going to be length times width times height. And we have all of those measurements already labeled. We have the length of this box right here, we've got labeled as 14. Then we're going to multiply that by the width, which was the 64 minus 2X, times the height, which is labeled as X. So imagine we are multiplying length times width times height, and the result then will be our volume. Now I'm going to go ahead and just reorder this. I like to write the 14X in front. Remember, you can do that because you can change the order in which you multiply. And we're just multiplying 14 times the quantity 64 minus 2X times X. So I'm just reordering my multiplication. And then I'm going to go ahead and distribute. So 14X times 64 will give us 896X. And then 14X times the negative 2X will be negative 28X squared. So here's our volume function. Now, because I specifically said I wanted a function, I'm going to actually go one step further and write this using function notation. So this is volume as a function of X, V of X. And I'm also going to reorder this. I'm going to write the negative 28X squared first. You don't have to do that. That's not a requirement. But we often like to write the term that has the largest exponent first. So negative 28X squared plus 896X will give us the volume of water that this rain gutter can hold as a function of X. Part B, what value of X will maximize the volume of water that can be carried by the gutter? So take a look at this volume function that we have created and notice that it is degree 2, so it's a quadratic function, and it also has a negative leading coefficient. So we know from our study of quadratic functions that that negative leading coefficient will cause the parabola to open down. So therefore, the maximum is going to occur at the vertex. So we essentially need to be able to find the vertex of this quadratic function. And we know that there's a handy formula that gets us the vertex, which is the opposite of b over 2a. So in this case, our b value is 896. So that'll be negative 896 divided by 2 times a, and our a value is negative 28. So negative 896 divided by 2 times negative 28. Grab your calculator, and definitely be careful here using your calculator, because if you are not careful with parentheses, you're going to have an error here. So either you enter this as a vertical fraction on your graphing calculator, or you have to have this additional set of parentheses to make sure that you're dividing by not just the 2, but also the 2 times the negative 28. And this will give us 16. So again, don't take my word for it. Be sure you're checking this on your graphing calculators. So we would have 16, and this is the value of x. Remember, x was the number of inches from the edge. So this would be 16 inches. That is going to be the distance from the edge where we want to make the fold to create the gutter. And then finally, part C says, what is the maximum volume? In other words, we need to find the y value, or the output, when the x value is 16. And this is as simple as finding v of 16, meaning we're substituting 16 into our volume function that we created to get the max volume. So that's going to be negative 28 times 16 squared plus 896 times 16. Go ahead and compute that. Check your answer with mine. I'm getting 7,168, and that's a volume, so that would be cubic inches, or inches cubed. This would be the maximum volume that the gutter can hold, the maximum amount of water. And to create a gutter that holds this much water, we would have to create the folds 16 inches from each of the edges.